Hello and welcome everybody to Lab 4. I know we're all excited to get started soldering, but I do want to start this on the computer because installing the Raspberry Pi software to our microSD card takes a long time. So what I want you to do is insert your microSD card, and we're actually going to go to the internet to download our etching software. What etching does is basically downloads an operating system onto our microSD card so that we can use it later on. So in Firefox or in Chrome or whatever your preference is, we shall go to Raspberry Pi.org/software. That will take us straight to the Raspberry Pi operating system website, and we're going to go down here and download for your preferred system, Mac OS, Linux, or Windows. I'm going to download for Windows since this is a Windows machine, and I'm going to save this file. Now we're going to let that download, and we'll be right back. Okay, welcome back everybody. We are all installed for me. I hope you are as well. And we're going to open this file. Now it's going to ask if we want to allow Raspberry Pi Imager to make changes to our device, and we're going to say yes because we need it to etch onto our microSD card. This is going to bring up our Raspberry Pi Imager setup, and we can actually close this internet browser now. We're going to click install and let it start installing all of the packages, and we'll be back when it's done. Okay, it is finished. And now we're going to make sure that we're checked Run Raspberry Pi Imager and click Finish. And this should pop right up. Now it is popped right up, and we have a very simple system right here. We're going to choose our SD card. I'm choosing my micro SD card. And then we're going to choose our operating system. Our operating system that we're going to choose today is Raspberry Pi OS 32-bit, the big giant one right on the front. And then we're going to choose Write. It's going to let us know that everything on that microSD card will be erased, and we're okay with that because it's a brand new microSD card. And we say okay, and now it's going to start writing. This is perfect time to now go into our soldering as this is writing. Hello everybody, and welcome to Lab 4, where we're going to be soldering our do-it-yourself Geiger-Müller device, or as we like to lovingly call it, the DIYgm. Now I went ahead and got everything out of our kit that I think we'll be using today. And hopefully you don't have to use all of this, because some of this is for fixing mistakes, but I think anything that we could ever use is in this little frame. So let's go through some of what we have. First things first, down here we do have two tweezers, one that's bent and one that's straight. We will be using these as they'll help us put in components. They aren't super necessary, but it's nice to have them. Next, we'll move on to our flush cut pliers. These are designed for after we solder something to the board. They have a nice flat end on the other side that we can use to cut something flush with the board so that it's not pointy and scraping us. Next, I think our main thing, other than our soldering iron up here, our main item here is these two pieces, which is actually our base of our soldering station. It's going to hold our soldering iron when it's hot, but we don't need to be using it. So we're actually going to assemble this right now. We have our spring system, and on here is two nuts. Ooh, let me try and get you in focus here. Here we have our spring system. On here is two nuts and two washers. We're going to unscrew the nuts, and you'll want to separate one of the washers out. And we'll leave one nut and one washer in place. There we go. So I have my nut and my washer. Then what we're going to do is insert it into this piece of the base, which allows us to add our nut and our washer to our other side. Add our washer, add our nut, and tighten that bad boy down. Perfect. And you really only need it finger tight, but I like to take the little wrench that they give us and tighten it down a little bit more, just because it'll give us some added strength from it twisting around a bunch and doing all sorts of weird stuff while we're using it. Perfect. Now that we've assembled this base, we really don't need this wrench anymore. You can put it back in your kit or set it off to the side. The next thing, we have wire strippers. We'll need these towards the end when we're soldering our two alligator clips onto the board. Here we have a sponge which we'll use to clean our soldering iron tip. Here we have some copper wick, which is used to clean up mistakes if we have any. But to also clean up mistakes, I find copper wick very difficult, so we also have this, which is called a solder sucker. And what we can do with this is basically, if we have an issue, it's a little suction pump, and when you have a board, let's say we have this board, and we have a piece of solder that it's stuck on, we'll heat it up with our iron, put our solder sucker on, and press the button. It'll suck up the solder, and it's perfectly fine if you get extra or whatever in it. Hopefully you won't have to use that, but that is a good thing to have. Next, we have our flux, which when we're soldering, we're actually dealing with a chemical reaction, as all metals like to oxidize. But when metals oxidize, they don't solder together well. So what we use our flux for is that our flux actually creates a chemical reaction which removes the oxidation from metals. And so it allows us to add a little bit of extra flux in case we have an issue where our solder won't stick. Now, all solder, which is actually in this little clear tube right here, has flux already built into it in a little core in the center. But in case we need extra flux, in case we're having trouble getting it to stick or something, it's nice to have this little extra tub. Finally, we have our two pieces here, which are our soldering iron and our soldering tips. Now we're actually going to change the tip that came on our soldering iron because I find the tip that we were given in the soldering iron is a little too difficult to use, and there's a much better option in this bag. So in this bag of tips, let me focus you here, you can see the one I've already used, which is the center one. There is a chisel tip, a large chisel, a small chisel. Let me try and get you in focus here. There we go. A large chisel, a small chisel. We have this rounded piece that has a flat end on it. And then we have two pointed tips. We're actually going for this small chisel, so it's going to come to a point, but actually be flat on the end. Kind of like a snub nose. Let me pull this out and show you what it looks like. Here we go. So let's try and get you in focus. There we go. So it's this little piece. It comes to a point, as you can see, but it's also flat. This, I find, is much easier to use because it allows us to get a lot more contact with the board because it's so much wider. So, back to our big open view, we can take this soldering iron, and the way we swap tips is we'll actually pull off the little protective case, and here we'll unscrew the collet, which is this little piece right here. It might be a little tight, and once you unscrew it, it should slide right off. You can set that down for a second, and these tips just slide right out. You grab your new tip, slide it right on, take your collet back, slide it right on there, and tighten it. Now tighten it down real tight, because as this heats up, it will get looser. It's perfectly okay. We can technically tighten it when it's hot, but gets a little dangerous and I don't really like burning my fingers. Now, another thing about these, I've actually colored mine black. I colored my arrow black for the temperature so you guys can see what it is. I like to keep it just about like 350, a little under. And I think that's a great spot to have it. We'll go over if your iron's too hot or if your iron's too cold in a second, because I think that's also important, because the temperature might not always be correct on these devices. And with that, I think we have everything that we need to assemble our digim. We have our solder sucker, our solder, our flux, our soldering iron that we just changed the tip on. We have our sponge, which we can actually wet a little bit. You don't need it really wet. You can just dampen it, squeeze it out, and set it right here in your plate. We have our copper wick, and we have our wire stripper and cutters. We have our flush cut pliers and our tweezers, and I think that's everything we'll need to solder our digim. So let's go through everything that we got in our package. Now we do have 2 inductors, 2 tan resistors, 2 blue resistors, 2 diodes, which will be in this red and white tape. We got the Raspberry Pi that you guys purchased with an SD card. I just stuck it in there. We have 4 of these transistors. We'll use 2 per board. We got these big capacitors and these little capacitors. And then we also got our red and black wires. Now you probably got some extra pieces in addition to this, but I'm just going with what I think everyone actually needs for this project right now. Now this is for 2 boards each, so you can see I've already made one down in the bottom right. So let's look at that just to see what we're getting ourselves into. Here's the board we're going to be making today. You can see we have our inductor here on the right. We have our diode here. Our diode is specific to which direction it goes, so we'll have to make sure we line that up. Don't worry, we'll walk through it when we get there. We have our 2 transistors. They're also specific which way they go. We can go over that when we get there. We have our large capacitor here and our small capacitor here in the low-pass filter section. In the low-pass filter section is also our blue resistor, and our tan resistor is in the inverter section. So I took the liberty of drawing up a simplified circuit so we can talk about what's actually going on in a Geiger-Müller circuit. What we do is we have this whole area on the left going into our GM tube, which is actually our voltage booster. And the way this works is we have 5 volts coming from our Raspberry Pi that goes through this inductor, which is just a big coil of wire. Now, it's normally going through here because this is powered by our PWM circuit, and this is just basically a switch. When it's turned on, it allows electricity to flow through here and flow right to ground. And so our 5 volts goes through our inductor, goes to ground, and is very happy. However, when we turn this off, that means that no electricity can flow, and so we lose current. So because of our resistance going way up, our current is going down, but it's not going down fast enough, and the inductor really doesn't like change. And because the inductor really doesn't like change, what it will actually do is adjust the voltage based on magnetic fields to try and keep itself at an equilibrium. And so when it adjusts the voltage, it will spike the voltage, and because it can't go this direction anymore, it takes the next best path and goes through this diode. Now this diode just acts as a one-way valve. It means once we send electricity over, it can't come back, and that's all it does. So we send it over this diode and it gets stuck in this capacitor. And so capacitor 1C1 acts just like a big battery, and all it does is hold all this extra charge from when our inductor spiked the voltage because it was mad at us. Now the key to keeping a high charge here and getting a high charge here is to switch this switch on and off as fast as possible. So what we do is we use pin 12 on our Raspberry Pi, which is actually the pulse width modulation pin. And what it does is it creates a square wave, so it just basically goes from 0 volts to 3.3 volts and back to 0 volts as fast as it can. About 1000 hertz is what we have it set to do. And so it just switches this about 1000 times a second so that we can create that voltage up here on our capacitor, because our Geiger tube needs a high voltage. So I'm sure you all know how Geiger-Müller tubes work, so we'll say that we've got a click. A bit of ionizing radiation has come through the tube and created an electrical charge. So we now have the electrical charge go through a resistor and a capacitor. These are our low-pass filter. Basically all it does is it slows our electrical charge down, and it acts as kind of a buffer with this capacitor so that we can chop off that top section so that it's not too powerful going into our second switch, which is T2 here. So now we're going into this second section, which is the section on the left. This is our inverter. Now in our inverter, we have 3.3 volts coming from the board, and it's always going into our measurement pin through resistor R2. Now what happens every time we get a click is that this switch switches so that the electricity that's going into R2, that's going into our measurement pin through R2, can actually go right into ground without a resistor. And because electricity likes to take the path of least resistance, it'll go straight to ground every time that we get an electrical charge. This allows us to create a voltage drop and spike back up to 3.3 volts on our measurement pin. And our measurement pin just reads every time that we get an increase in electricity. And so every time this goes down, when it comes back up, we read it as a count. And that's really the basics of how this system works. All of this is just to get us about 350 to 400 volts. It goes through our tube. When our tube gets a click, we soften it out so our transistor doesn't get blown up. Then our transistor will just switch on and allow the electricity to flow from our measurement pin, instead going straight to ground, allowing our measurement pin to see that it's lost voltage, gain voltage back again, and count a click. So, for our first section of soldering, I want to do these three pieces. I want to do the two resistors and the diode. One thing before we set this all up, this can get kind of messy because the flux likes to run, because when it heats up it just turns into a really viscous liquid. So it's really helpful if you want to solder this on a plate or something else. It's not going to splash or get really messy, but just underneath it can kind of get dirty on the table, and it's just easier if you put something underneath of it. I like to take a paper plate and cut around the outside so you just get a flat disc and set it on top of that. So now we're going to be putting these components into this board. So let's start with our diode. Now with our diode, the way you take these out is you just grab the paper. Let me try and get you in focus here. There you go. You just grab the paper and you pull on this wire. And it can be a little tough, but you pull it right out. And it'll bend, that's fine. We'll do the same thing to this side. Perfect. This we can set off to the side in case we mess up. And now we have this diode. So, to put this diode into the board, one of the main things, because we're working with this diode, and this diode is polarized, you can see the little band drawn on here is the same as the little band on our diode. That's what you want to line up. You want to make sure the gray line is with the white line on the board. The way you set this up so that it goes nicely is you insert the diode about like that. Let me adjust your focus. There you go. And then we bend it right over. Now to measure out the next one, I take it, look at about where it is, and use my fingernails, and then I'll just bend it right over my finger. That gets me this nice little shape like this, and that's perfect. We'll take and put one end in here, press this other end just so it goes in, and then you can use, got a little bright there, you can use your fingers and just press on that diode just to get it through. If it's having a little bit of trouble, you can always pull from the other side, and that can often straighten it out. And that looks great. So now that's right on our board. Now, to hold this one in while we're putting in the other ones, we can just bend these arms out a little bit, and they'll stay just like that. So now, we'll do the same thing with our next piece. Let's go with our tan resistor. Sorry, I got a text right there. Let's go with our tan resistor. Now our tan resistor will make sure to check our other board. Our tan resistor, as you can see from this board, if we're lining it up, goes in this R1 spot. So, we'll go over to R1 and put the one side into the board. Same thing, we'll get it about lined up. Let me get you in focus. Perfect. we'll get it about kind of where we want to bend it over, grab it with our fingernails, and bend it right over our finger. Now, it's perfectly fine if you don't get this exactly lined up. It's really easy to fix. You can always unbend it, rebend it as many times as you want. You also have that second one. We'll insert one, bend the other, make sure it goes into the PCB. Press that down with our finger and that sits in just perfect. Now, just like this diode, we're going to bend these legs out to hold it in position. Perfect. Now our last one that I want to do right now is going to be our blue diode. So we'll pull our blue diode out of its tape. Perfect. I'm just going to straighten this guy out a little bit. That's straight enough. And now our blue resistor goes in the R2 slot. Now these resistors are not directional, so it doesn't matter which way you put them in. You can see I went a little too far on that one, so I'll just bend it back. Stick it through the hole a little bit more. And then bend it right over. Just like that. And then we'll line it up with our fingers. Grab it. Make sure it can pull out. It helps. Sometimes it just gets a little stuck. So let me line this back up. Okay. Make sure it'll come out of the PCB. Bend it right over. And perfect, just like that. It doesn't have to look pretty. It'll look great when you put it in the board. And then you just push it right on through. Ooh, you can see that one's having a little bit of trouble going through. It bent right over when I pressed on it, which is fine. Just straighten her out and pull through with your fingers on this side. And that can sometimes help. It's definitely not rocket science. Sometimes you just gotta use some manual persuasion. There we go, perfect. Sorry, I think that was off camera, but you can see that I just wiggled it around and pressed it down enough to get it through. We'll spread the legs to hold it in place, and now perfect. These guys can set right on the ground, right on our paper plate, and we can solder right to these. So now let's go through some of the soldering, because I do want to be able to talk with you through it before we're in the rush of having a hot iron in our hands. So, you're going to grab your little tube of solder. You can see I've soldered a little bit with this already. Pull off the top and pull it out of its bag. And you can actually leave the solder in the tube like this. That's perfectly fine. But take the end of it and pull the end out. Just enough to straighten it out. Get a little bit of solder. Perfect, just like that. So, the way we solder is we're going to hold this just like a pencil, and we'll hold our soldering iron the same way, just like a pencil, right up next to the grip. Let me get you in focus so you can see that. Right up next to the grip. We'll zoom out. Perfect. And we'll hold it just like this, just like we're going to be writing. And now, the way we'll do that is when we're going to solder a piece, what we want to do is we want to make sure our tip is flat, and you want to go right up against the board. Let's zoom in actually. Perfect. Get here, and you'll go right up against the board, and you want to press your tip to the gold plate. You want to make sure it's touching the gold and up against the bar of the diode. You don't have to push that hard, you just want to make sure you're getting contact. And if you're getting contact, you'll add your solder to the other side of the rod. And this way you know that when the solder is melting, it's going to connect with both of these items. It's going to connect the gold plate to the end of our diode, which is exactly what we want. Now, if you're having trouble connecting, you can always try to add a little bit of solder to the tip, actually, of the soldering iron, which will help it get more contact because the solder will actually join up here. And then you can go back to adding solder like this. Another thing is if it really, really won't work, you can always take and open your flux and just lightly dip your soldering iron in a bit of the flux. Now your soldering iron, when it's hot, will be hot, so you want to do this slowly so you don't splash a bunch of flux around. It'll slowly warm up the flux before you dip it, and then you can always go right back to it. That will help remove the oxidation and make the soldering process much easier, but we're just going to go like that. Okay, so now, two things. You can see I've zoomed out enough here. We're going to put our soldering iron into our holder before we plug it in, because we don't want it just getting hot on the table. The next thing, don't forget to wet your sponge and place it here for cleaning our tip. Now, you're ready to plug in your soldering iron. So when you plug in your soldering iron, it's going to immediately start heating up. It won't take that long to heat up. Let me reach by you. Perfect, my soldering iron is now plugged in, and it's going to immediately start heating up. Now, a good way to tell when it's warm is now we can grab our soldering iron. While it's heating up, that's no issue. I'll just set this right over here. And a good way, we'll zoom in, to tell when it's up to temperature or when it's heated up enough, is you just kind of touch it with your solder. And you'll eventually, as you touch it with your solder, as it's heating up, you'll eventually start to see the solder start to melt into the tip. Now, it'll start just by a little scratch, kind of, and then it'll actually turn into a full liquid like this. You want to have it heat up until you can just touch the solder and you don't even notice about the point where it melts. So around here, I can just add as much solder as I want, and there's no issue. Well, trying to get you in focus here. There we go. So right here, I can basically add as much solder as I want, and I don't even notice it going away, which is perfect. Now we have quite a bit of solder on here, so I will wipe it on my sponge. Perfect. You can see that little blot of solder. That's perfectly fine. We'll focus back in here. We aren't under a ton of rush here. You can see I've got a nice shiny silver soldering iron now. Make sure you have enough space to move. Make sure your soldering iron is flat, and then just touch it to that pad. Make sure it's touching the pad and touching the bar, and you add solder from the other side, and you just add enough until you see some of it melt in, and that's it. You'll just go here, you'll touch both sides, you'll add a little bit of solder. Try not to touch the tip of the bar, because that will heat up. I definitely just got myself there, but that's not that big a deal. These are a little harder because they're a little smaller, but it's not too bad. You know, just a little bit. Make sure you're touching the board. Focus on touching the board, but you don't have to really contact it. You can just press them kind of between the two. And you only want to add a little bit of solder. Now I'm going to add a ton of solder here just to show you what that looks like. And most of it is actually, funnily enough, going to stick to my soldering iron, because that has a lot of what it wants there. So this is actually too much solder on this one. And you can see, if we look at it from the side, that on these, trying to get that in focus, perfect. Now on these ones over here, we've got these nice little peaks, nice little mountain hilltops. Now over here, when you add too much solder, you'll get kind of a blob or a round piece. That's when you know you've put too much solder on, and the way to get rid of that is just to take your soldering iron, just put it against it and wipe it up the bar. We'll actually be cutting these bars off anyway, so it doesn't super matter if you get a bunch of solder up here. You can see it's kind of messy up there. That's perfectly fine, because now we actually have a nice clean mountain of solder right here at our base, which is perfect. We'll cut the rest of this off so it's not that big a deal, and we can do our last one. Now, one of the things, if our soldering iron is too cold, is not warm enough, you'll actually see a really interesting thing happen. As you add solder, it'll be perfectly fine. But then when you take the soldering iron away, the solder, instead of staying this nice shiny silver like this, will actually immediately flash to like a hazy color. And when it flashes to that hazy color, that means it immediately oxidized. So it's too hot and it burns off the flux too quickly. So what we do there is we'll take and we'll just turn the dial on our soldering iron to a lower temperature. You can see I'm still around my 350 degrees because that's working perfectly for me. But in case that's not working for you, you can always turn it up a little bit if it's too cold. And if it's too hot, you'll actually start burning the flux right on your tip. So when you add a little bit of solder, it'll turn brown so quickly that it won't actually be able to, you won't be able to hold it and talk like I am right now. So if it's too hot, you'll be burning it on the tip, and if it's too cold, you'll see this stuff flash to a hazy silver. So as long as you don't do those two things, if you see one or the other, you can always turn it down or turn it up. Otherwise, we've just soldered our first 6 pins. And they look great. So I'll wipe my soldering iron off. And if it's easy for you, you can unplug your soldering iron right here. It's not that easy for me, so I'll just keep going. And you can definitely leave your soldering iron plugged in. It actually has an auto shut off, so if it sits there too long, it'll turn itself off. Now we're going to come in with our flush cut pliers, and you can see on these pliers, they're actually flat on one bottom, and you can use that to get right up next to the PCB. I suggest holding the tip of this with your finger, because if you don't, they'll go flying. If you do, you can just give it a little cut, and this little piece comes off, and you can set that off to the side. We'll do the same thing right here. We'll go right here. Oh, moving my solder around, sorry. We'll go right here and cut it off. And same thing with these two. And there we go, we've done our first 3 pieces. They look great, they're nice and flat, they aren't going to scratch anybody, and they're held right in place. Now you can see on this board, there's a little bit of residue around them. That's actually the flux. The flux is kind of a jelly consistency, and then when it dries just like this, when it's not warm enough. So what we'll do at the end, if you really don't like this, it's perfectly fine if you leave it there. It's not going to hurt anything. If you really don't like it, we can always take, at the end, we'll take some isopropyl alcohol and wipe that off, and that'll go right up with the wipe. So now, we have our first 3 pieces, and they look great. After our first 3, we're going to go with our capacitors. These light blue squares. We have one small and one large. And the way I take these out is I actually take my fingernail and I'll scratch at this tape and I'll pull them right out of the tape. You can always, if you don't have fingernails or if you aren't willing to scratch at them a little bit, you can always just bend them over and cut them right off with your flush cut pliers. And I'll show you how you do that too. So you can pull them right out of this tape just like that. Or you can just bend them right over, take in your flush cut pliers, and cut them just like that. Because technically we don't need them that long. This is perfectly long enough. I like to have the extra length, so I always just pull them out of the tape. It's not that big a deal for me. But depending on how much struggle it gives you. we can always do that. I'm going to do the same thing with this little one. And sometimes when you pull the tape down enough, you can just pull them out, just like we did with the resistors. And now we have our small and our large capacitor. With these capacitors, if we look back on our original board, you can see the big capacitor, the big square, goes on this side with the diode, and our little capacitor goes into our low-pass filter. So, these are actually really nice because we don't have to bend them at all. They should be perfectly sized for the capacitors. And you should just be able to line up the capacitors into the holes and push them right through, and they'll fit perfectly. Just like that. Now mine bent over a little bit because I pushed too hard, but that's perfectly fine. Remember to bend your legs out, that'll make it easier for it to stay in there. And we'll grab our little capacitor, and we'll do the same thing over here. Now remember, these actually don't matter which way they go. These are non-polarized capacitors, which means you can stick them in any direction. So just line up the two spaces, and it slides right in perfectly. So now these two, we're going to do the same thing. You can bend this right over. And now we'll grab our soldering iron, plug it back in if you've unplugged it. I haven't, so if you didn't, just add a little bit of solder to rewarm it back up. You can see all this smoke. This smoke is actually the flux burning, which is perfectly fine. It should evaporate just like that. It's nothing dangerous. And then we'll take and we'll make sure you're perfectly in focus. Here we go. And we'll take and we'll press this to the board, and we'll add a little bit of flux. And the flux melts perfectly, and it's quick. You can see I've added a little bit too much there. So I'm going to take and wipe my soldering iron on the sponge, and then take and wipe this and slide it up the tip. And as I do that, it takes some of the solder away from the joint and brings it up the bar of the capacitor, which is perfectly fine because we'll cut that right off. You can see I've got a little bit of a mound up here, which is perfectly fine. And then we'll just add to the board over here. Make sure you're touching the board, make sure you're touching the tip, add a little bit of solder, and that's perfect. We'll go to this next one. If you start to run low on solder, you can always just grab it with your fingers and pull out some extra. Make sure you have enough so that you aren't getting your fingers real close to this iron, because this iron is hot. Take and touch the board, touch the tip, add a little bit of solder, and it really shouldn't take much. Really, if it starts to melt and you know it's melting into the board, that's good enough. You can see I've got a little bit of mess here. That's really no big deal. We'll be cutting it off. No one will know the better. And that is our two capacitors. Great job, guys. You can put your soldering iron back in its holder. We'll grab our flush cut pliers, and we'll cut those right off. Make sure you're touching it with your finger, or else it'll go flying around your room. I don't want to tell you how many times I've lost one of these pieces in my room, and you know, it's like playing Where's Waldo, except if you don't find Waldo, he stabs you in the foot. So I don't recommend it. Now our capacitors are on there just perfectly. Now, the next thing I want to solder is our inductor, which is our round cylindrical thing right here. It doesn't matter which way it goes in, but it does go where the circle goes. It's our only circular device, and it goes on the circular part of the PCB, which makes sense. Now, one of the things about this inductor that we have to pay specific attention to is these stubs are really short, so we actually can't bend these rods to hold it in, and also our board really likes to fall over. So what I like to do is I like to take my flux cap and put it right under our board here so that it doesn't bend over as much. And then we're ready to solder. So we get our nice long piece of solder. We make sure we're in focus. Perfect. We'll grab our soldering iron, and we'll just touch it there, and make sure we're touching our base and our rod, and that's perfect. Done just the way we like it to be done. Now you can see I've actually got a little bit of extra solder here, which is why we always check our work. And we'll just wipe that off a bit. And that's perfect. Now if your soldering iron is ever being too much of an issue, or it doesn't seem like it's exactly acting right, you can always just lightly touch it to your sponge, wipe off some of that solder on it, and that can usually help it out. Now, the next thing I want to do is these transistors. These transistors are actually directional, so we want to look at the base of our transistor that goes where the white line is here. So they face to the left, just like this. And we'll grab our second transistor and put it in over here. And then we'll flip this right over. These are technically one of our hardest pieces to solder because these are so close together. But we did make the pads a little bit larger to try and help out with that. And another thing about these larger pads is you'll notice it might take a little second longer to heat up than the other pads. And try to make sure you aren't touching more pad than one more. Try to make sure you're only touching one pad at a time. They will take a little second longer, but not that much. If you're having trouble getting to heat up, make sure you're touching the PCB and make sure you're touching the leg. Now, one of the things is, the reason it takes so much longer to heat up is because, one, we have to heat up more of a pad. These pads are larger. But two, we also technically, as we're heating up one rod, we're heating up the other three. So we have to heat them all up at the same time, which means this outer rod, or the first rod we do, will actually be the longest heat up, whereas this one takes the shortest amount of time. Now we'll take and inspect those. It's perfectly fine if they're bent. If it really matters to you, you can heat them up and push them over. I wouldn't recommend it. I think it's perfectly fine bent, and we can actually bend these up with no one being the wiser. And they'll look perfect. We can return our soldering iron to the holder, and we'll grab our flush cut pliers to cut these off. Don't forget about your little inductor pieces. Now, one thing about these guys, these transistors, is they are much larger, so they hold a lot more heat. So you want to make sure that you don't grab your flush cut pliers and start cutting on these right away, as they are quite toasty when they're first done being soldered. And after you cut those off, you can see we're down to our last piece, which is actually our jumper wires. But look at that, you guys did a great job. You soldered something perfectly. Now, let's go to our jumper cables. For our alligator clips, we'll take these out, and we actually only need half of these. So you'll take them and fold them in half so that the alligator clips are all at one end, and you're holding the other. And we'll take our flush cuts, and we'll go right over these wires, and we'll split them in half. It doesn't have to be exactly in half, just close enough. And that's perfect. So now we have these two pieces. You can set one off to the side. And now we just have these wires with alligator clips at the ends. So with these wires, let's do one at a time. We'll take our wire and we'll insert it into our wire stripper at the second to smallest point, just so it slides right on through, and you want just about kind of half of your one knuckle to your index finger. And then you'll take and you'll press it down on this end, and you'll take and you'll spin this wire. And what we're doing is we're cutting the outer casing of this wire off, and then you can actually take, and as you're still squeezing, just slide the wire out, and you can see we've cut this rubber off. This rubber can be set off to the side with all the posts. We'll throw it away. And this is our nice shiny copper. We'll take and we'll spin this in our hands so that we spin up this wire all nice and straight into one straight line. We're going to do the same thing with our black wire. Oh, sorry, I bumped you. Do the same thing with our black wire here. We'll stick it through the second to smallest hole. Stick it out about, there we go. If you're struggling a bit, you can always press back here, and that'll lift up this jaw enough so that you can slide the wire right through. And you only need about, again, half of your index finger. So we'll press down, we'll spin this wire around, and now that it's spun around, we'll slide right back out. We can throw away our rubber. We have our nice, I want a nice dark red background. Let's use this flux cap. There we go. So now we can focus in here. You can see we've got all this copper we'll take and we'll spin it in our hand. Perfect. So now we've got this nice straight piece of copper wire. What we're going to want to do is these wires are actually going to go through the last pieces in our board here, right here and here. So what we're going to want to do is we want to tin the tip. Copper really likes solder, but it doesn't as much like gold. So what we're going to do is we're going to add solder to the copper first, because solder is perfectly fine joining to itself and joining to gold. So the way we do this is we'll put our soldering iron underneath of our copper wire, and you can just set it so it's leaning against your flux cap, so it's just sitting up out in the air. And we'll take and we'll put our soldering iron on the underside, and then we'll just add solder right to the top of it. And so you'll want to just kind of heat up the copper, and you can press down on the copper with your solder so that the copper heats up to take on this solder. And that's perfect. So now you can see instead of this gold copper, if I can get us in focus, let me set my soldering iron down. Instead of this gold copper, we actually now have a nice silver tip. And so let me compare to our red one here. And so you can see the difference where our solder has actually penetrated and joined up with our copper, which will make our job a lot easier. One of the things about doing this though is it's really easy, when we're doing this, it's really easy to add too much solder to the end so that it won't actually go in, into the hole in the board. So be careful that you don't add too much. If you add too much, you can always, again, wipe it with your soldering iron. Take this and just press the red wire into your soldering iron. Just add a little bit of solder. Don't need to go crazy, but you want to make sure that you're touching the wire. And that's perfect. Now I had a little bit of extra solder, and you can see I've got a little bit of a blob here and a blob here. So we'll just take and we'll wipe those down so that we get a nice clean line. Perfect. And that's great. Great job. We've tinned both of our wires. And now that our wires are tinned, we can bring our board back in and add them to our board. So, on our board, the red is actually going to go in the left hole. That is our anion, or our anode. And it doesn't have to be way through the board. You can see I still got a little bit of a splotch on mine, but that's perfectly fine. It just needs to be enough through that we can solder it from the other side. And you can always just brute force it a little bit too. We'll push that back so that it holds it in place. And we'll grab our black wire. And our black wire is going to go on the right side. That black wire goes right through. And we'll take these two and we'll flip them over. And don't forget to fold your black wire over. And now, we'll zoom right in on these guys. We'll grab our soldering iron and our solder, and we'll solder for our last time. And then after we solder this last piece, I'll actually go through how to remove stuff. and how to fix our mistakes. So we've added our solder there, touch our pad, touch our wire, add a little bit of solder, and that's all we need. And that's perfect. We'll set our soldering iron back, we'll grab our flush cut pliers, and we'll cut these right off. Perfect. And just like that, we finished our board. Great job, you guys. Welcome back from the soldering, you guys. I hope it went very well. And now you can see that our write has been done. It tells us that it was written perfectly fine, and we can remove the SD card. So we'll click continue. We can actually close this software and remove our SD card. Awesome. Now that we've got our micro SD card all flashed, you can take it and insert it into the micro SD card slot here, so it's facing the board. Then we'll take our digim board that we've soldered, and you'll want to add it so that the cords are facing away from your Raspberry Pi. And it might be a little bit of a tight fit, and it'll slide on there. Then you can take your Geiger tube, and what we want to look on specifically on the Geiger tube is there should be a plus stamped on the Geiger tube. That will attach to our red wire, and then our black wire will attach to the other end. So the way we do that is we just take it, open your alligator clips, and slide it on the side just like that. And then we'll do the same thing with our black wire. And that is attached just perfectly. If this rubber falls off, it's no big deal. You can just slide it right back on. And sometimes they'll bounce off of the Geiger tube, so make sure you get them on there nice and good. And that should be all set. And one last thing I want you to take notice of is our HDMI port is right here. That one you can't mess up. But these other two are very specific, so you'll notice right above them, one says USB and one says power. So you'll want to make sure that you choose the right one. I'll plug in my USB adapter here. And then I'll bring my power cord over, and I'll plug that in. And when you plug in your power cord, you should see a little LED right by the power light up, and that's when you know your Raspberry Pi is working right. Okay guys, welcome to the Raspberry Pi that we just started up. So we'll be running through the setup real quick here. So click next to get started. We want to set our country as the United States. We're going to want to use American English. And our time zone, make sure to set your time zone. In Ann Arbor, we'll set it as Detroit. And make sure to click Use US Keyboard. And now it'll set our location. It'll take a minute to do this, so we'll come back when it's done. Okay, now that our location is set up, we can actually set up a password. Now I recommend you do this, but for this demonstration you can definitely go without setting up a password, so I'm going to skip that. Now if you have a black border around your screen like we do, you'll just check the box to change the black border when it resets. And we'll go next. And now you're going to set up Wi-Fi. I entrust you all know how to set up Wi-Fi, so I'll let you get to that, and we'll come back when we're done. So, now we've come to a very important step. It's asking us to update the software. We're actually going to skip this because I found it kind of glitches our Raspberry Pi Zero W quite often. And now our setup's complete, so we can restart our Raspberry Pi, and I'll see you when we get back. Welcome back to the Raspberry Pi. Now we're going to be installing all the software that we need to run our digim. Up here, we can actually go up into our console. And as this loads up, I'm going to open this up and actually expand it so you guys can see what I'm typing. If you want to do the same, you can hit Control-Shift+, and it'll just zoom in. Now the first thing we're going to do is type sudo apt-get update, because we didn't run the updater the first time. We want to run it this time. It might ask for your password if you inserted a password. For me it doesn't because I left it empty. Okay, you can see I didn't have to update anything, but you might have to. Now we can update our Bluetooth, so we're going to write sudo apt-get install python-blues, B-L-U-E-Z instead of S, and we'll let that run. It's going to ask us if we want to use extra memory. You'll just hit Y and press enter for yes. Perfect. Now that Python Blues is installed, we can install PyBlues by running sudo pip3 install, if I can spell it, pyblez PyBlues. And this pip3 might take a little bit to run. It does have to aggregate a lot of information from your Raspberry Pi. So just let it sit there and run. It'll figure itself out in a few minutes. Perfect. Now that we've installed PyBlues, we only need to add one more thing. We're going to download the software for our DIGgm. So we're going to go git clone, and now we're going to insert a website, https://github.com/ in all caps UMRHE, and then lab with a capital L /DIYgm with capital DIY. And you'll press enter, and it'll clone that into our file system. Perfect. Now that that's installed, we have everything we need, so you can close out of the console and open up the file system up here in the top left. Now in this file system, you can see we have a file named DIGgm. We'll go into that, and then we'll be going into the DIGgm Raspberry Pi only for right now. And we're going to open that up, and it should take a second to load because it's going to load into our Python code executor. Great, now we're loaded into our Python executor. So you can see down here is our console where we're actually going to get readout. And this is all the code that we are using to run our DIGgm. So as long as you aren't touching anything, because this will get to about 300 volts, 350 to 400, we're going to hit run. And if your tube is plugged in, you'll see it says about 100. Now, one of the things we found out with these new Raspberry Pis is that the pins are actually a different length. So we're first going to try and hope that your pins are the correct length in one of the older Raspberry Pis. So you can bring your FiestaWare closer to it, and you should see counts go up. If you don't see counts go up when you bring your FiestaWare close to your DIGgm tube, you can take and just press on the Raspberry Pi a little bit and lift up on your DIGgm board such that it kind of leans upwards a bit, just so that you can get connection between the front pins and the back pins of the Raspberry Pi. And you can see now that it says about 100. It'll be between 100 and 102. And when you bring your FiestaWare closer, it'll jump up to around 200, which means your Raspberry Pi is working perfectly. So I'm actually getting about 165. If I bring my FiestaWare closer and put it basically on top of it, I get 240. You can see it's actually working perfectly. Now, if yours isn't working, you can always talk about some reasons why you think it doesn't work in your answer instead of how it worked. And then I think that's all we need for this lab. So you guys are all set for this week. You should be able to fully answer all of your questions. We can now stop the code. Hopefully you've had a great time learning to solder with me, and you've got an awesome DIGgm setup that we can actually go more in depth with next week, so make sure you hold on to it. And I hope you guys had a great time. Thank you for hanging out with me for this lab, and have a good rest of your week.